Good morning, everyone. I am Dr. K. Naveena Latha, Assistant Professor in Mechanical Department in Mlritm. Today, I am discussing a course on unconventional machining process. Let's see what are the modules which are present in the unconventional machining process and what is the difference between conventional and unconventional machining. So, before going in depth into this course, unconventional machining process, let's see what are the objectives. After finishing of this course, uh, how the objectives will work out for the students. The students can understand the principles and machining methods and what are the maximum metal removal rate for the various machining process and what are the limitations for the different materials and for the complex geometries. And coming to the course outcomes, students can easily understand the basic techniques for the unconventional machining process. And for the various machining process like plasma jet machinings and abrasive jet machinings, and easily they can understand the what will be the maximum material removal rate for the thermal metal removal process like plasma laser jet machining process. And even they can easily understand the principles and maximum applications of EBM, electron discharge machining process, with a complex metal geometries, and what will be the economy which impact for the different parameters. So before going to the topic, first we'll see the what are the modules which are present in the unconventional machining process. So here we have a 5 modules. In the first module, we should know the what is the difference between this conventional and unconventional machining process. And what is an ultrasonic machining process? What will be the maximum material removal rate? And water jet machining, we know the principles and applications, limitations, and what are the parameters which influence the increasing of metal removal rate for ultrasonic machining process. In the second module, we should know the what are the other machining process like electrochemical process. In that, we should know the fundamentals, how the energy is converted from one source to another source, and how the machining methods varies like electrochemical honing, deburring, and other process like grindings. And even we can also know the what is the maximum metal removal rate in ECM, and we should know the impact of various parameters to increase the metal removal rate by this methodologies. In the third module, the other source of energies like thermal material removal rate. By this energy, what are the techniques which are used to machine the different materials like electric discharge machining, wire discharge machining, laser beam machinings, plasma arc machinings, and electron beam machinings. From all these machinings, we should know the what will be the maximum material removal rate, what are the impact parameters, and what is the limitations, advantages, and disadvantages among all these machining methods. In the fourth modules, other different type of an energy source, because here we are using different energy sources. From each source conversions, we are removing the metal removals from the various materials. So in the fourth modules, by the applications of like abrasive flow machining. So by this technology, how the metal can be removed and what are the advantages, and which field this type of machining can be used. And other technologies like magneto, abrasive flow machining. So these are the different machining methods which are present in the fourth module. So we can easily understand all the concepts one by one. And in the fifth modules, we have different technologies, like we called as in hybrid technologies. Before 4 modules, individually we should know the one by one the machining techniques, but in the 5th module, combination of 1 and 2 technologies, we are removing the materials from the various materials. So these are the few textbook references we have presented here. And these are the references which I have mentioned here for the unconventional machining method technologies. Now, introduction to this today's topic in UCMP. It is also called as an unconventional machining process or non-conventional machining process. So, the first one is the introduction of this non-traditional machining methods. So, before going to this, first of all, we should know that what is the conventional methodology. So in conventional methodology, or we also called as a traditional methodology. So these traditional methodologies are like turning, milling, drilling. So these machining methods we are using since long times, but in a modern engineering which needs a high precision, accuracy, surface levels, toughness, and it requires. So in advanced materials, which is very difficult to machine by these conventional methodologies. So these are the limitations which we have observing from the conventional methodology. So to avoid such a difficulty, we are going for the unconventional machining process, where there is a lot of development in the machining technology. So first we'll see this conventional machining process. So what is the definition of this conventional methodology? It is nothing but it's a metal removal process from the workpiece in the form of a chips by using a sharp cutting tools. So these cutting tools are single point cutting tools or multi-point cutting tools. So what is the basic principle behind this conventional methodology? So in conventional methodology, the metal removal will occurs by the use of mechanical shear actions, shear force actions. So here the tool must be very hard compared to a workpiece. And the energy sources which are used in the conventional methodology as the mechanical energy. There is no conversion of one form energy to another form. Only a mechanical energy which is utilized to remove the workpiece material. So there is no conversion of chemical, electrical or thermal energy which have implemented in the non-chemical machining methods, or we simply called as an UCMP, unconventional machining method. So here in the conventional method, the chip formation, which may be a continuous or a discontinuous depending on the type of tool which we are utilizing for the removal of work material. And here in the conventional methodology, the heat is generated due to the friction between the tool and the workpiece. To avoid this thermal impact on the surface of work material, we have to use the coolants. And the type of motion which have include here in the conventional methodology as primary motion. The tool can be linearly, it can be moved, or depending on the geometry, depending on the application, the tool can be rotated about the 360 degrees also. And the feed of motion as given depending on the geometry and depending on the shape of a requirement. So these are the few common conventional machining process like turning, drilling, milling. So these are turning operation which can be done by use of this lathe machines, and drilling which can be used by the drill machines. The point here is the difficulty which we are facing with the conventional machining method is the accuracies and surface finishes, and even the level of micro-sized holes are very difficult with the use of this conventional machining process. And to get the high precision surface finish, which is depends on this parameters, like temperature and tool weights, and which improves the surface finish. So even though we are doing all the machining methods by conventional method also, but why we are going for non-traditional machining? So these are the four major challenges which are not possible by conventional methodology, like hard material challenge. In conventional methodology, if we want to remove the work material from the work surface, the tool must be very hard compared to our workpiece. But nowadays, in modern industry technology, they are using a high treated alloy steels, which is a very hard. So it is a major challenge in the industries. So we go for to avoid such limitations, we go for non-traditional machining and for complex geometries. Some products or some industries like aerospace and automobiles, we need some intricate internal cavities and micro features. With the non-linear counters, it requires a tool accessibility. Sometimes there is no contact between tool and the workpiece. So these are very difficult in the conventional methodology. So to avoid such limitations, we are going for this non-traditional machining and damage-free processing. This non-traditional machining is for a few technologies, even we go for damage-free processing because there is no contact between tool and the workpiece. So delicate parts or thin-walled structures need machining methods that minimize the mechanical forces, thermal damage, and residual stresses. Next major challenge is precision requirements. Modern applications demands a tolerances in a micro levels and the surface finish unattainable through this conventional means. So particularly for an aerospace and mechanical devices. So what is the classification of this unconventional machining? So these are in the previous slide we have discussed because of those limitations which are not done with the conventional methodology. We are opting for the non-traditional methods. So in non-traditional method, how this can be done with the classification? So the classification is based on the energy utilizations. The first one is the mechanical energy. How the conversion will take place. So initially the electrical energy which is converted into a mechanical energy by this energy source which is used to utilize the removal of metal from the workpiece. So by using this mechanical energy process, there are the three machining methods are there. One is the ultrasonic machining, abrasive jet machining, water jet machining. Which we also called in a short form as an USM, AJM, WJM. And the second energy source is the thermal energy process. In non-conventional method, thermal energy process, how this thermal energy is utilized to remove the work material from the workpiece. So here are the conversion of from one energy source to another energy source. So initially the supply of power and voltage which gives an electrical energy, this is converted into a thermal energy. By the use of this thermal energy, the metal can be removed. And in the third energy source is the electrochemical process. So conversion of this electrochemical process technique is used to remove the metal from the workpiece. Next, the fourth energy source is the electrical discharge process. So here the metal can be removed by the use of spark erosion between the electrode and workpiece. So here we need to connect electrode. Electrode is act as a tool here and the workpiece. So the electrode will be connected to the negative terminal and workpiece is connected to the positive terminal. So there is a spark generation. So this spark generation which removes the work, which melts and removes the work material from that particular localized area. Then how to select the non-traditional machining methods? The correct selection of the non-traditional machining methods must be based on these following aspects. One is the physical parameters of the process, next shape to be machined, process capability, and economics of the process. What are the physical parameters we need to consider to choose the non-chemical machining methods? So these are the parameters like potential volts, current, power, gap between the tool and the electrode, and type of medium which is used in between the tool and the workpiece. Let us take, we'll see one by one each technology or each machining methods in the further classes, but let's see now the parameters are utilized in different unconventional machining methods, like in ultrasonic machining. In a short way we called as an USM. Here the voltage are utilized in 220, like current will be 12 and power 2.4 kilowatts, and the gap between the tool and the workpiece has 2.25. And here the medium between tool and the workpiece is an abrasive, which is used in the flow of liquids, that is water. Similar way, there is a different technologies like abrasive jet machining, chemical machining, electron chemical machining, electron discharge machining, electron beam machining, laser beam machining, and plasma arc machining. Among all these machining methods, if you see here, electron beam machining and laser beam machining requires the high voltages, which we should handle very carefully. And here, if you see the accuracy levels also, it will be more compared to our ultrasonic machining and abrasive jet machining. And this, when we are going for laser beam machining and plasma arc machining, which uses the oxygen and hydrogen gas as a medium to remove the work material from the workpiece. Shapes cutting capability. So depending on the geometrical cross sections or geometrical complexity of the object, we need to choose the machining process. If you want to produce the micro holes, 0.01 to 0.05 levels of micro holes want to drill, which is not possible with the conventional methodology. This we can produce by laser beam technologies. And similar way, for a small holes, like 20 to 50 we can go for the electron beam machining, and for the deeper holes or a counter hole or an intricated hole, like in aerospace fields and automobile fields or in medical fields, we require the micro levels of precision holes are required. In that case, we use this type of machining techniques. Similarly, for a honing, etching, grinding, deburring, these are the machining methods we are used for depending on the application, depending on the machining technique. Capability to shape. So, if you want to drill the micro shape holes or cavities or pocketing operations, or throughout the surface, if you want to cut the material on the work surface, these are the different machining methods we are utilizing in a different way. So P, F, G, these grades are indicates the poor, fair, and good. If you see, suppose ultrasonic machining, this machining methods generally it is utilized for brittle and ductile materials, and this will be used for the depth of cuts. Not for, it cannot be used for the micro drill. So it is better. It is very poor in a micro drills, and it is very like a ring surface. It is not possible with the ultrasonic machining. It is good in what? It is good in only for drilling of L/2 ratios, like diameter minimum 20 diameter. It can be easily drilled by using this ultrasonic machining. Similarly, it can be used for cavity sinking also. This ultrasonic machining is very good for accurate operations and standard operations also. And these ultrasonic technique, which is very poor for doing shallow pocketing and deep pocketing. This, it can be done with the laser and electron beam techniques. hybrid process in UCMP. So, in the four modules, we have discussed individual technology, individual machining methods one by one, and this in the fifth module, we in this module we are discussing the hybrid process techniques, combination of one and two. For example, like in a grinding. This grinding technology, it gives not a high accuracy of the workpiece. It will not provide the high accuracy of the workpiece. So, to get the high accuracies, again, this process we can do with some other technologies. Like we can go for the ECM or ECH, electrochemical machining or electrochemical hornings or deburrings. These are the other techniques which can also be implemented to get the high surface finishes. Here some of the few hybrid process which I have mentioned, like electrochemical grinding, combination of electro discharge machining and ultrasonic machining. Electro discharge machining, initially it gives some sort of an accuracy level. To get the more accuracy, again we can opt the same workpiece in this machining process also, so that we can get the good surface finish. So the workpiece must be free. It is a burr free surface, and even we can utilize for the hard materials. And similarly, laser assistant machining method. Laser assistant machining method, it is a combined mechanism of laser heating and conventional cutting. Initially, by using of this laser rays or laser heating energy, we do initial machining, and after once it done, this can be using with our conventional methodologies, even we can get the more surface finish even for harder materials. So these are the few hybrid processes are also implementing nowadays in a modern industries. They are using to get the high level of precision of jobs to get the good surface finish. So, in further sessions, we'll discuss individually each and every machining process and its applications, limitations, what are the affecting parameters to increase the metal removal rate for the each machining process. Thank you all.